então, para a gente ficar no horário. A gente está começando hoje, então, o terceiro dia da Escola de Inverno de Ciências da Aprendizagem. Obrigada pela presença de todos, né, pelo comprometimento e participação de vocês na semana passada. A gente espera que hoje e amanhã sejam dias bem produtivos também. Hoje o dia vai ser bem interessante, a gente vai começar com o keynote da professora Yasmin. Ela vai fazer um keynote com o título Projetando para o Erro, uma perspectiva construcionista sobre como apoiar experiências bem-sucedidas de aprendizagem. Depois a gente vai ter uma mesa redonda com o professor Matthew Berland, com a Grace Pérez e com a professora Michelle Wilkerson, sobre desenho de ambientes de aprendizagem com equidade em ciências, engenharia e computação. Daí a gente tem o nosso intervalinho. Depois a gente vai assistir um vídeo que o pessoal do Japão mandou para a gente. Eles têm um grupo lá de ciências da aprendizagem, um grupo irmão do nosso aqui. Então, eles vão falar sobre lições aprendidas, experiências da implementação e expansão do campo de Learning Sciences no Japão. E, por fim, a gente vai ter um momento de debate, a gente vai ter quase 2 horas para debater entre nós aqui numa sessão fechada, né, sobre os participantes, sobre perspectivas para ciências da aprendizagem no Brasil, onde a ideia é que vocês tragam ideias, né, de como é que a gente pode ampliar o campo, discutir juntos, pensar em estratégias. E, por fim, a gente vai ter meia horinha de networking, né, para vocês baterem papo aí sobre coisas não necessariamente relacionadas à pesquisa. Então, para essa última sessão, a Tati e o Renato prepararam uma enquete sobre temas que vocês têm interesse em discutir nessa última sessão, para a gente agrupar vocês por interesses, né, por coisas que vocês queiram discutir. Então, eles vão mandar as instruções e o link aí no chat ao longo do dia, preenchem para a gente poder organizar melhor aí no final. E um último recado é que na próxima semana a gente vai enviar também os certificados para vocês, tá bom? Então, fiquem tranquilos que a gente está preparando e em breve vocês vão receber. É isso, eu vou passar para o Paulo agora, apresentar a professora Yasmin e iniciar a sessão.
Obrigado, Cássia. Então, hoje a gente ter a honra de ter a nossa última keynote, a professora Yasmin Cafai, que é uma pessoa central nas ciências da aprendizagem, mas também no construcionismo, que muitos de vocês conhecem. A professora Yasmin fez doutorado na Universidade de Harvard, mas interagiu muito com o Seymour Papert e com o grupo dele no MIT durante muitos anos, e é uma dos principais nomes no construcionismo e na ciência da aprendizagem, pioneira em várias áreas, por exemplo, na área de e-textiles, né, que são esses novos substratos para papel, tal, trabalhou muito com isso. Depois, mais recentemente, trabalhou muito em biomaking, né, que é uma modalidade de educação maker com biologia. Escreveu vários livros sobre esses assuntos e ela tem, ao longo dos anos, avançado a fronteira do conhecimento, tanto em Learning Sciences como no construcionismo, e tido um papel muito importante do pensamento do Seymour Papert, da Cynthia Ackerman, todos esses pensadores para o coração das ciências da aprendizagem. Hoje ela é professora titular na Universidade da Pensilvânia, no programa de Learning Sciences, e tem tido uma influência muito grande no campo, então é um grande prazer ter ela aqui conosco. Então, Yasmin, I don't know how much you got of that, but take it away. Thanks so much for being here.
All right, thank you, Paulo, very much. I admitted everyone, but now somebody else needs to do the business of getting you into the Zoom room. Thank you very much for
the
kind introduction, and let me start and share my presentation. So the title of my presentation is Engineering Failure for Learning. And oops. There are three parts to the talk. First, I want to talk about the perceptions of failure. And then secondly, about how we can kind of shift to a different approach to failure, thinking about failure. I call this failure by design or debugging by design. And what kind of lessons we can draw from this approach for rethinking failure for learning. So those are the three parts. And in education, I mean, as you know, we cherish success and fear failure. But as you also know, not every project, not every learning is a success right away. In fact, making mistakes and fixing them is the norm rather than the exception. So my talk today is about finding a different, more productive approach to make failure a successful learning. And in the business world, as many publications attest, people have long embraced failure as learning as an opportunity on the way to success. And the titles you see here of the books are just really a small selection of the hundreds of titles which are available. And people have even created a fail festival to kind of talk and celebrate their failures. This has been going on for many years and in multiple countries around the world. And there is also in design a Museum of Failure and Innovation, which opened up in 2017 in Helsingborg, Sweden. And the museum showcased failures to provide visitor a learning experience about the important role of innovation and to encourage organizations to become better at learning from failure. Its collection of failed products and services actually traveled all over the world. But then also in science and engineering, we have a similar positive stance towards failure, very well known as Henry Petrovsky's work To Engineer is Human, who studied the failure of bridges and its impact on improving their design. And more recently, a book by Mario Livio, Brilliant Blunders, I think the title says it all, pointed out the important role failures play. But when it comes to education, we see failure in a very different way. And these are just a few of the selection. The shelves here are full of books that detail how school, teachers, and technologies fail learners. Yes, we want students to be successful right away and all the time. Failure is not considered an option. So how can we adopt a more positive stance towards failure? Some people have tried. There is, for instance, a recent Kickstarter campaign, the failure toy, which showed actually the designer talked how hard it was to design a failure toy. And I would be amiss not to mention the work of product by Manu Kapoor, who is now at ETH Zurich, who has coined the term productive failure. He found out that students who first experienced failure in working with ill-defined problems were later significantly more successful in solving the very same STEM problems when compared to students who did not have that failure experience. In my own work, and I'm sure probably also in yours, I have seen tons of examples of failure. As Paulo already mentioned, I work right now in computer science education with a group which is called Exploring Computer Science. And we've designed a curriculum that lets students explore electronic textiles, articles of clothing, accessories, or home furnishing with embedded electronic elements. And let me show you a few examples of what that actually looks like from a video, so you get a better sense on who the students are and what they do. Okay. Can everybody hear? Can you show me?
Programming, I've never done anything with computers in general.
So I thought it was like all about computers and stuff. Yeah. But it's not.
I thought it was going to be a little bit harder to do.
At first I thought you had to be really smart to
Code.
The e-textiles unit covers a series of different projects. Each one builds on the next. The students start out by making simple circuits and then eventually making parallel circuits with switches and computational circuits that they can program in customized ways. The programming includes a lot of challenging concepts, basic sequences, embedded conditionals, Boolean statements, mathematical operators, using sensors, and thinking through the logic of how to program those sensors. It's not just crafting, it's sewing combined with circuitry. I love what you might call the hybrid nature of e-textiles.
to see the possible connections between crafting, computing, and engineering.
Our e-textiles unit seeks to bring making into computer science classrooms. We want to broaden who is participating in making in computer science. We want to deepen their learning by providing meaningful challenges to students. And we want to diversify who is making and what they are making. We're doing this by focusing on student-driven handcrafts.
The electronic crafting projects are not so much about teaching students stitching. Involves a lot of problem solving and thinking about procedures and steps, which I think connect very closely to thinking about computing and procedures.
But it's that transformation from their original ideas to what works and learning the skills, both programming skills and circuitry and crafting and all of those ways that those interweave.
It's usable. You can take it home with you.
Kids come in at lunch that I've never seen ever outside of the classroom without me asking them to. They just come because they want to do extra work or they want to make sure their project works.
I like to do challenging things.
So I think this should give you an idea that these kind of activities can not just take place in makerspaces, but actually in classrooms, in large high schools, where we have now worked with hundreds, if not thousands of students doing electronic textiles as part of their introduction to computing. No, sorry, it's not, that's not. So, and as part of the project, students actually design a series of projects, and invariably, tons of mistakes happen in the crafting, in the design of the circuits, in the coding, and how they all relate to each other. We actually interviewed students about the debugging challenges they had. And as you can see, they're fairly distributed across the three areas because each of them alone is difficult to learn. But the connection of them, of crafting a circuit which is functional, which works, as well as programmable, actually turns out to be fairly complicated. And these are three-dimensional projects which the students create. Here's an example of, a simple bag where you can see the front side, the crafting, as well as the back side on the top. But then look below on the circuit design, which underlies the structure. And to the right, you have the code, which students have written to make the elements on their back interactive, responsive to certain designs. So plenty of opportunities to make mistakes. So, but rather than, making like Manu Kapoor in Productive Failure created the problem situation for students, with a constructionist bent, we thought that the learners, the students themselves, actually could become the designers of failure artifacts. So failure by design is an approach where the students are learn about failure by making bugs or debuggers to solve for others. And how do we implement this? So in this curriculum, which you just saw, first of all, we make a hall of failure, where students who have already worked on 3 projects list all the problems they have encountered. And as you can imagine, most students have probably only encountered 1 or 2 bugs, but a class of 30 or 40 students has way more bugs. So students in their gallery walk actually get to see a whole range of bugs related to crafting, circuitry, coding, and design. Then students are asked to plan and design a failure artifact, a debugger, for other students in their class to design. So they have to decide on the level and types of bugs they want to include. And after that, they actually make the buggy circuit. I mean, as you can see here, they build it, and then they hand it over to peers in their class who are tasked to make, this electronic text file to fix it. And after that, we'll have a discussion at the end. So this is like a 7 to 8 lesson unit, which now is becoming part of the e-textile curriculum. So here is a closer look at a debugger. It's called the barfing rainbow. We have not created this. And some of the bugs are very clear. When you look at the bottom of the page, students put typos in variable names. This is what I would consider a very low-level bug, or they delete information. But on the top, there's actually intentionally deceptive code because they initial all the different LEDs they have put in to go at the same time, even though the program is supposed to do something very different. So even in making bugs, you can do easy and you can do difficult ones. And as a second aspect, we were very interested not just in what kind of bugs students create, but also whether actually their mindset about failure changes. And there is very famous research by Stanford professor Carol Dweck about growth mindset and fixed mindset, which actually applies really well to debugging. Students who have a growth mindset think about, I love a good challenge, I wonder how I can fix this bug. But many also students see debugging really with a fixed mindset. I keep making mistakes, I'll never be good at coding. And so there's actually quite some research which has established the relationship between debugging and growth mindsets. But most approaches when we teach people about debugging is giving them checklists, strategies, or problem sets, which are designed by others. And likewise, when we look on how we teach students to kind of develop this important growth mindsets, we give them lectures. We tell them what that means. Or we tell them saying is believing, like when you start programming, you just say at the beginning of the lesson, I'm good at coding, and you watch testimonials. So with our approach, we actually take a very different situation. We not only have students design the bugs, we also give them an opportunity in the process to become more confident. And here are some of the examples, what we saw in classrooms when students were debugging the problems. So they chose challenges that were not just easy, which also led to more learning. So students started to include music, something which we actually had never done in the project in their e-textiles. So they had to learn about doing this. Students also, while they were designing the bugs or the mistakes, were giving and valuing praise for efforts among each other, kind of being supportive. They were persisting after setbacks because often the first effort didn't really lead to what students intended to do. And they approached learning as a constant improvement and see what else they can do. Most importantly, students actually became comfortable with failure. So they looked at their crafting, can positive and positive cross each other. They looked at their coding, they messed up. And they also realized that these things could actually, you know, what needed to be perfect, what kind of had some room for mistakes. And that is an important learning lesson as well. So these are just a few glimpses of this intervention where the students became the designer of and solver eventually of failure artifacts. And here are two broad outcomes. Both, I mean, for the growth mindset, we saw that in the process of making these failure artifacts, students started to feel more comfortable with problems in their own assessment. And these actually were significant pre-post survey results. They also felt more confident and less stressed in solving problems. And they also felt more able actually to ask for help because a lot of people make mistakes, it's okay. And in terms of their own learning, I think it's also important to point out that students gained through the hall of failure, through making and solving bugs, as programming novices, which they were, a familiarity with a broader range of problems. And they actually all, after they finished debugging by design, worked on the fourth e-textile project. So they were able through this also to avoid mistakes in later projects and identified problems more easily and also learned new code. An important part of this whole process were also the teachers who shared and celebrated mistakes. For instance, we saw teachers in the classroom calling out their favorite mistake of the day to highlight what is possible. But teachers also showed mistakes in their own project. Here's an example of one of the teachers who you saw in the video. And she points out, look at my stitching. These are some good stitches. These are some bad stitches. What are the bad ones? The long ones, the long ones. These are me being lazy. So I think that is another important component, that the focus wasn't just on students' mistakes, but also that the teachers, part of this learning community, showcased and identified their own. And the teachers who we worked with, who implemented the debugging by design in their classroom, noticed that a lot of students became mischievous when they realized, oh my God, we get to mess with other people. So this was an unattended side effect of the project. They also saw a lot of problem solving, that students actually had to think through all the different things that could go wrong and trying to plan them in advance to make something like click it. And that's usually not necessarily an approach you take when you work on writing a program. You're just trying to get finished. And students also make a lot of connections between the different aspects which they had not made earlier. So some key takeaways from this instructional intervention of having students rather than teachers or designers make failure artifacts is that when we put learners in control of their own learning, that learning about mistakes by making projects for their peers actually also generates what we call growth mindset practices. And I showed you a number of them, which we actually saw the students doing. And Dweck and Jaeger in a review actually pointed out that this is one of the more productive ways to get students to embody a growth mindset set. That designing mistakes is actually a whole new area of holistic growth and CS education. and that our design-focused practice-first approach may help to promote a growth mindset in computer science and make students actually feel more comfortable in a field that many feel disenfranchised. And debugging is a holistic process where motivation and emotion play an important role that we can address through designing failure artifacts in a very productive way. I want to point out, I mean, the mindset practices and artifacts are, of course, an important point, but we also have collaborators at the University of Colorado Boulder. This was a project initially started with the late Mike Eisenberg. And we have a number of computer science and engineer students there actually developing new tools, software libraries, as well as probes and simulators for helping students to become better at a whole team, including Deborah Fields, who you saw in the studio, and graduate students, and Luis Morales Navarro in particular, who conducted the study on the growth mindset practices, and teachers like Jake Ships and others who have participated in this project. So for you, in closing my talk, Engineering Failure for Success, I would like to encourage you not just to celebrate successes, but also to celebrate mistakes, and maybe to organize a hall of failure rather than, I mean, the hall of successes, to share mistakes in your own project and research, and maybe to think about this approach that your students or learners can actually become designers of bugs for others. Thank you very much.
Muito obrigado, professor Yasmin. Eu vou falar em português, tá? Para a gente seguir aqui. É o Renato falando. Muito obrigado. A gente está começando a receber algumas questões e comentários dos participantes. Eu vou começar com uma pergunta que eu tenho, que acho que talvez outras pessoas também tenham, que é sobre um comentário, né? E eu queria saber os seus pensamentos sobre isso, que muitas dessas atividades envolvem costura, né? Algumas atividades de arte, bordado, algumas atividades que são, que em muitos ambientes, principalmente em idades, né, adolescência em diante, são vistas como atividades de meninas, ou de, né, e talvez deixam alguns grupos de lado, mas que, por outro lado, pode ser inclusive para pessoas que pensam de formas diferentes também, né? E eu quero saber quais são os seus pensamentos sobre isso, se são atividades que também conseguem atrair pessoas que convencionalmente podem se ver como incapazes, entre aspas, de programar, de se desenvolver como um programador, um cientista da computação, ou simplesmente ter um letramento em computação.
Thank you for this question, because I was focusing so much on the debugging by design. I didn't talk a lot about the genesis of the electronic textiles, which a dear colleague of ours, Leah Beakley, who was actually a student of Mike Eisenberg's at the time, developed when the Arduino came on the market. She decided to customize it for making interactive variables or electronic textiles, because she felt when you looked at what people were making with the Arduino, it was mostly robotics, cars, kind of the typical stuff we associate with computer science and engineering. But she also conducted a study with Benjamin Marco Hill, and she examined what kind of projects people were making with the Lilliput Arduino, and she found a very different type of projects, you know, which involved soft textiles, arts and craft, as you already mentioned in your question. And isn't it interesting? It's exactly the same technology, but by the way it's kind of designed, it invites different, participants. Over 90% of the participants were women, whereas, in the case of the robotics and cars, it was exactly the opposite. but it also invites different types of projects. And I think that is very important when we think about broadening participation in computing, who we want to bring in, but also when we think about broadening perceptions of computing. So who do we think should participate? What is computing about? And I have to tell you, the students we work with in exploring computer science all are in under-resourced communities. Many of them are 100% minority. So they're not your typical high schools. This is the first class for many of them in computer science. They're often very surprised. They thought you never would do something like that. And we also need to realize that we value certain technologies and activities differently and more than others. So we consider something like computer science, like microcontrollers, high tech, and something like sewing and textiles, low tech. I mean, just by giving these names already, we assign different values. And as you pointed out, these are highly gendered activities and materials. But as you could see in the video, the boys are into fashion too. They may accessorize different types of clothing or different themes. So it is actually an activity which invites all groups. And we noticed during the last year when we were teaching e-textiles online, so students were at home, it also brought in a lot of family members. I mean, aunts who knew how to sew and could contribute. So I think that is an important aspect. I'm not saying everything should be e-textiles, but it should definitely be part of the larger repertoire on how we think about introducing computing into K-12 education. That was a very long answer, sorry.
Ótimo, a pergunta foi longa também. Tudo bem. A Kátia tem uma pergunta aqui, né, sobre o papel dos professores também. E que ela diz que o problema começa com professores que abordam a ciência na escola e não demonstram para os estudantes que a ciência e os experimentos só existem em função de erros. Então, como mudar esse mindset em educadores e qual seria a principal ação do professor?
Let me give you a background. Exploring computer science is a project which was started by my colleague Jane Margolis more than 15, 20 years ago, when she noticed that a lot of schools in poor neighborhoods didn't have any access to computer science. And so she created, together with Joanna Good, a one-year curriculum so that students got a broad introduction to web design, Scratch, data, a whole bunch of things. You can go all online and look at the curriculum and download it for free. But they also realized that professional development was really critical in building a community of teachers. So these teachers, when they not only learn the technical skills, they have a particular emphasis on promoting equity in their classroom, on bringing students into computer science, into participating and helping them learning these skills. And to continue their development, we're actually right now working with a nationwide community. There's about 3,000 high school teachers in the United States. I'm helping them to learn about electronic textiles. And one thing which we observed when we were going into a classroom, I mean, you saw some pictures of all the stuff which is here. The classroom actually turns into a maker studio at that time. It's a mobile, it's not a permanent maker studio. And lots of things are happening. The students are all working on individual projects, so they don't have the same circuit designs. So we realized that this was a real challenge for most teachers to manage, I mean, this call for assistance, I mean, helping students to deal with bugs, but also helping the students become experts so that they can help others. So the debugging by design essentially picked up on successful practices which we saw the teachers use in the classroom, the celebration of mistake. I mean, on highlighting mistakes, making them visible rather than making them disappear under the table, and by giving students intentionally some more experience. There is nothing surprising when you start out new in a field that you really don't have a lot of experience with mistakes. You're a novice. Somebody who has taught a class over multiple years has seen many, many mistakes, and for them, it's much easier to find a solution. But for most students, that's not the case. So the debugging by design makes it more transparent. It also helps the teachers to get students involved to support each other. And that in the long run creates a much more equitable classroom environment where students can take over and assist each other and let the teacher help, I mean, when it kind of gets really critical and complicated.
Legal, muito obrigado. O Rodrigo faz uma pergunta aqui que eu gostaria que talvez seja uma oportunidade bacana para você também falar sobre o background e um pouco das escolas em que esses experimentos, essas intervenções são realizados pelo seu time de pesquisa. Ele pergunta como usar o fracasso produtivo com estudantes com baixas autoeficácia e um mindset fixo, né? Que algumas pessoas do campo, né, podem se preocupar que para alguns estudantes, se eles não são apropriadamente motivados ou apoiados, essas tarefas podem aumentar, né, um comportamento que pode impedir o progresso deles.
Thank you for bringing up this point. This is really a valid concern, you know, and I know this when I show the business books, you know, that often these are written by people who obviously have been successful later on and are cushioned in their faults. So it makes for a great story when you can talk about a failure in business, but you are eventually very successful later on. And we all know that for students from under-resourced, low-income communities, that is definitely not the case in their life. Also, the experience they had in school, and failure is really an emotional, but also academically very risky business. And so we're fully aware of that. And so I want to tone down my rhetoric about, you know, turning failure. But the situation is when you get into computer science, and Seymour Papert was the one, you know, whenever you write a program, you always make mistakes. There is no program which runs, I mean, failure-free the first time. It's just, I mean, a situation. And I believe this is also true for many other activities like writing. You don't get the first perfect sentence right away. You have to kind of work on it, chisel at it. And I think that is an important learning experience for students that, I mean, we often portray learning as, I mean, a gradual increase. I mean, so you always get better. And we forget that, I mean, these moments when things don't work, when you have to go back and rewrite something, or when you have to fix a code, are an essential part of the learning process. And the people who have done microgenetic studies and shown that, I mean, it's not that steep increase. I mean, learning actually is having some success, and then you kind of go back, and then you kind of move up again. It's a constant back and forth. But in our portrayal of learning, we only often look at the end product of success. Oh, that's what counts. And we forget that the path is much more cumbersome. And then I think with something like debugging by design, we're trying to make that transparent, and we're also trying to make it intentional so that students realize mistakes, bugs are just a part of the learning, and let's figure out a way on how we can kind of be more proactive. We can be in the driver's seat, and hey, by making a buggy project for somebody else to fix, you are in the driver's seat. And I mean, you decide what the mistakes are, where they go, if they're hard or easy. Now we tell students whatever they make, their peers have to be able to fix within 1 hour. You know, and we also talk with them, what are easy, what are difficult ones. I mean, just deleting lines of code is easy, but not necessarily productive. So it gets actually students, one of my graduate students, Gayatri Ayathurter, she is looking at, this is a very technical term, notional machines, like mental models. It actually gets students to think more deeply about what a program is, how a machine functions, or a physical computing artifact, in a way which they probably wouldn't do when they're busy on kind of making their design and making sure everything works. And I think that is a very positive, empowering learning experience for students, which we don't give often enough. And it's an empowering experience about process and bugs, not necessarily about the end product. So I think, you know, since exploring computer science is nearly in only underperforming low-income community schools. Most classrooms actually have little to no white students there. So we have shown that in these kind of contexts, you can conduct these projects and empower students to feel more comfortable. We don't necessarily use the word failure, but dealing with bugs and fixing their programs. And knowledge, which, by the way, in the beginning, they're often very confused, but when they come to the next project, they then feel more comfortable. And we all know practice makes perfect. And when you're a beginner, you have written maybe a handful of programs, so nobody can expect you to be actually very proficient.
Legal, muito obrigado. Acho que você começou a sua resposta falando sobre algo que acho que está bem conectado com a pergunta do Marcelo, sobre a ideia, sobre o conceito de sucesso, né? De que diferentes estudantes podem ter conceitos diferentes de sucesso, e como isso pode estar conectado com a motivação que eles têm, né? Então, o Marcelo pergunta se essa noção, né? Se o sucesso dessas atividades depende de oferecer oportunidades, de se oferecer tarefas que os estudantes tenham uma motivação autônoma. Então, talvez você possa comentar sobre outros tipos de atividades, né, que possam ser, além de stitching, né, de atividades com artes, que mais podem ser usados na sua experiência, assim, que pode ter esse papel de aumentar a motivação, ou de aumentar essa sensação de sucesso dos estudantes.
As I mentioned, electronic textiles are just one example, and the efforts to put computer science education into K-12 are now a global effort. I mean, on all continents, and I think what we need to do is to come up with a whole variety of different projects, not just robotics, not just games. And I say that having done game design projects for nearly 20 years, I think these are all great activities. It's like in any English literature class. You don't just want to read the big words of Shakespeare, the big names. You want to have a whole array of literature, many of which also connect to where students are coming from. And likewise in computer science, we need electronic textiles, artificial intelligence, even the kind of robots you made in music and art. There is, in data analytics, there are so many different contexts you can apply this to. But unfortunately, often when students start out, they have a very narrow perspective on what that is, what people do. And so I think one of our responsibilities as educators is also to broaden these perspectives and to introduce students to new, and moreover, to also engage students critically in what the shortcomings of technology are. So the electronic textile curriculum, the last project is, a sensor hoodie, where you essentially take human, we're all conductive, you have sweat, but our conductivity is different. So you actually have to write the input for the sensor data to be flexible to different types of people. It's not just one way. And you can think begin very critically on how a lot of technologies are not designed this way. I mean, they only assume that users are a particular type. They don't pay attention to differences. You can look at how a physical computing system is really a large category. The robotics are part of it. A lot of systems like your red light system. I mean, that even in your whole home, you have a lot of devices now which fall into the category of physical computing. So you cannot only begin for students to understand the technical aspects, but also the critical aspects as well, by designing activities which help students understand that everything we do in technology is designed. I mean, somebody made the decision on how that pixel on the screen looks, on how that button, what it does and what it doesn't do. And I think that is, an important aspect. And we need a wide array of activities in order to help students understand that. And that will also, in the long run, makes them, prepares them better for their roles as kind of competent citizens and interacting with technologies and giving feedback to companies and governments when decisions are made. I think most people don't feel very empowered because they feel they don't have the tech knowledge to participate in these kind of conversations.
Muito bom. A gente vê a gente nota, né, no Exploring Computer Science, que é uma iniciativa super ampla, que envolve muita gente, né? Tem recursos para gestores, para educadores, para estudantes, né? Então, é uma iniciativa que está toda, ela tem uma aparência bastante completa, né? E a Mariana faz uma pergunta sobre como começar, pensando que essa é uma mudança de mentalidade que envolve pessoas com interesses muito diferentes, com demandas muito diferentes. Então, a Mariana pergunta: por onde começar essa mudança de como a comunidade enxerga a educação?
Oh, you're asking me to solve all the problems in education. Come on. I'm working on one small slice of computer science education as an example. I learned a lot from what Jane Margolis and Joanna Goode did. They did a very careful study of different high schools first on what was happening. And then they decided, when they started the program, not just to start with one group. They involved teachers, administrators in the school district, and they build up capacity. So when teachers come and join this project, they're actually required to come back and induct the following year the next group of teachers. Right now in the United States, and I believe that's true also in many other cases, there's often only one computer science teachers in a school. There is really no professional community. So that's something we need to build up. And I think it's a really good model when we think about change, that we're not just focusing on one group, but that we really take this more holistic approach and long-term perspective. We realize that changing people's perceptions, getting them involved in equity-oriented teaching is not something which happens with just one workshop. it's a longer process, and you can build up capacity this way. So I'm very fortunate that I don't have to do the work right now. I'm just tapping into this pool of exceptional teachers and facilitators. And there are now whole school districts, like the school district of Chicago, which is one of the largest in the United States, and New York. Every student takes exploring computer science. And so we're building community, and we're supporting teachers also, as well as with administrators. So in Los Angeles, which is the second largest school district with about 800,000 students in the United States, there are now people who started out 15 years ago. They're very high up in the school administration. And the reason, you might have noticed, I actually live on the East Coast in Philadelphia, 2,500 miles away from Los Angeles, but all the research takes place in Los Angeles because I have very easy access into schools, classrooms, and teachers, which I don't have yet here in Philadelphia, which is a kind of different setting. So, I mean, you're putting your finger on a critical issue on how do we bring about change. But change isn't just the technology. It is great that the Lilliput Arduino, the microbit, I mean, there are Adafruit. We're actually not working with the Lilliput Arduino anymore. We're working with the cheapest technology we can get, because when you work with thousands of students, that really becomes a critical issue. So you do need the technology design. I mean, I think Leah Beakley showed very eloquently that, I mean, it makes a difference on who gets invited, what gets designed, and who participates. But we also need teachers who understand how to work in those schools and not just have the technical knowledge, but also bring the equity perspective in their teaching and making sure that their classrooms don't disenfranchise students, especially since they're already working in schools where the large majority of students are students of color. We also need a professional community to support teachers in their continued development. So a lot of teachers from ECS who came to us because they had worked for 5, 6, 7 years, they were ready for something new. Right now, all of our efforts are focused on inducting new teachers, and we're kind of forgetting about the teachers who are already, I mean, more experienced, but they need continued professional development as well. So it's a very complex problem, and I'm sure I can solve it. I have a very small sliver of what I'm kind of working with, a very small, dedicated group of people in addressing, and there's much more, obviously, which needs to be done. And we don't have those, I mean, big resources. We're not a company. You know, we have 2 people who work on curriculum development. We're not a textbook publisher with a big team.
Muito bem. Professora, a gente tem um ditado aqui no Brasil que diz que tudo que é bom dura pouco. E a gente está acabando agora. Infelizmente, não dá para abordar todas as perguntas que tem aqui, mas acho que a gente conseguiu cobrir várias questões, mas muitos comentários muito bacana. Não podia deixar de ser assim, né? Com tanta experiência, com um trabalho tão relevante para as ciências da aprendizagem como o seu. E o Paulo, eu vou abrir para o Paulo fazer uma última pergunta para você antes da gente encerrar. Mas muito obrigado até aqui.
Hi, yes. Você me ouve, né, Renato? Just a very quick question. I know this is like the first winter school in the learning sciences, and so many people here have never been to the conference, have never been part of this community. So how does it feel to be part of this community, and what's your advice for newcomers?
Well, actually, as a project, I think Mike Eisenberg, Leah Beakley were part of something, we're all part of the learning sciences. And I think it illustrates the interconnected nature when we talk about learning. So, there is technology design. A number of people in the learning sciences design new tools, software, activities. There are the teachers understanding where they're coming from, and there are also the students. I mean, what are their interests, their motivations, their connections, and there are the larger issues. And I think in the learning sciences, you will find a place which allows you to kind of work at the intersection of those issues, to realize that it isn't just the technology, it isn't just the teacher, or just a student. And I want to make clear, that the research psychologists and others have done to understand what students think, what are their challenges, and likewise, the research people have done on what teaching is, pedagogical content knowledge, practices. All of this is important, but when we come into classrooms, into learning environments at large, we are faced with very complex situations, and it is very difficult to kind of tease out one aspect. And I think in the learning sciences, people have been very successful to recognize and to value the complexity of learning, and also to develop methods to research this, which are not just kind of experiments, but kind of recognize that this is an ongoing process in how we improve educational practice.
Thanks, Yasmin. So, Renato, você quer encerrar?
Obrigado, Paulo. Obrigado por passar o microfone. E só queria agradecer a professora Yasmin. É um prazer tê-la aqui com a gente. A gente aprende muito sempre em todas as interações com você. Te agradecer mais uma vez em nome da equipe da Ciências da Aprendizagem Brasil. E quem sabe na próxima a gente se vê novamente. Muito obrigado.
Thank you very much. This was a pleasure. And at some point, I hope actually to meet people in person and not just as little square rectangular box on the screen.
Eu só te conheço em 2D, por exemplo.
Thank you.
Bye-bye.
Obrigado.
Thank you very much.
Pessoal, acho que agora a gente tem 2 minutinhos até começar a próxima, então se alguém quiser fazer um breakzinho rapidinho, temos tempo.
Quem quiser usar essa pausa para responder aquela enquetezinha que a gente enviou, posso copiar e colar o link aqui novamente. É bem 1 minuto, dá para responder. Só para a gente vai fazer uma sessão de bate-papo mais livre, né, no final do dia, e para a gente saber como é que a gente reúne em salas para que vocês aproveitem ao máximo esse momento.
Olá, pessoal. Vocês estão me ouvindo? Renato, a gente pode voltar já agora?
Claro, tá o microfone de vocês.
Tá
Obrigada.
bom. A gente vai começar agora a nossa segunda sessão do dia, com a professora Michelle Wilkerson, o Matthew Berland e a Grace Pérez. E o Paulo vai apresentar eles, depois cada um vai ter 15 minutinhos para falar, e no final a gente vai fazer uma sessão de perguntas e respostas. Então, eu agradeço se ao longo da fala deles vocês puderem já ir colocando no chat as questões, a gente vai ler elas ao final, mas vocês já podem ir, à medida que as questões vão emergindo, já ir indo comentando elas no chat para a gente ler no final. Paulo.
Olá de novo. A gente, então, agora ouviu a Yasmin falar muito de design e vai continuar um pouco nessa temática de design e ciências do aprendizado, também construcionismo. E a gente tem, de novo, um excelente painel com 3 professores, pesquisadores que aceitaram o nosso convite generosamente, então muito obrigado. E esse painel vai falar sobre o desenho de ambientes de aprendizagem e equidade em ciências, engenharia e computação. Então, a gente vai ter nossos 3 panelistas, a Michelle Wilkerson, doutora em ciências da aprendizagem pela Northwestern University e professora da Universidade de Berkeley, na Califórnia. Tem um trabalho espetacular na área de ciência de dados, e desenha muitos ambientes de aprendizagem, software, e uma das mais produtivas pesquisadoras da sua geração. Obrigado, Michelle. O Matthew Berland também tem doutorado na Northwestern University, é professor na Universidade de Wisconsin-Madison, nos Estados Unidos, também um dos grandes nomes na área de ciência da computação, desenho de software, de pesquisa nessa área. E finalmente, a nossa terceira panelista, a Grace, tem doutorado pela Universidade de Stanford, eu conheci ela lá, e tem um trabalho muito interessante na área de equidade no ensino de engenharia. Então, ela está agora concluindo o doutorado na Universidade de Stanford e começando como professora, ou talvez já tenha começado há alguns dias, na Tufts University em Boston, na área de Boston, onde ela vai desenvolver esse trabalho sobre ensino de engenharia e equidade. Então, os 3 têm essa expertise na área de ciências, de engenharia, de computação, e vão falar um pouco sobre o trabalho deles e delas nessas 3 áreas. Então, Grace, Michelle, Matthew, thanks for being here. Thank you so much, and take it away.
E o Matthew Berland vai começar.
Hi. So I'm going to start by saying, please feel free to interrupt me. Feel free to challenge or ask any questions, but I'm going to try and keep this pretty tight because I'd love to answer questions rather than blather. So yeah, I'm Matthew Berland. I'm from the University of Wisconsin-Madison in the USA. I'm an associate professor. And the talk is about what we're really wanting to teach when we want to teach with computational content, like to teach computer science, this kind of thing. So I do want to say, like, that I didn't do any of the things that you'll see alone. These are all parts of big teams, and if anything, I mostly hindered the work that they were doing rather than helped. And so I will do my best to represent their work well. But the big question that I ask in a lot of my work is how can we use social spaces, collaboration, coding, play to help students build what I call creative agency through computational literacy? Now, those are arcane terms, even in English. I have no idea how they will translate, but I'm going to do my best to give you my definitions of what these might mean. So the big thing is that I'm often trying to teach what I call creative agency, which is not just the tools that you need, right? Not just the stuff, not the computers, but rather the skills, the resources, the social support networks, all these things that you need to create, that you need to express yourself, especially with computation. And the key is that this is made up of both the ways that you interact around code, the things you decide to build, and the kinds of things that you do build, and how that interacts with the power and the social structures that you're embedded in, both inside classrooms and outside of classrooms. Basically, I want kids to be able to express themselves. I want to use computation to help them do it. And so how can we do that in a playful, creative way? The ways, the means that I use, I think about this in terms of what I call, or lots of people call, computational literacy. I'm breaking it down in a specific way, which is, again, to take the focus off of just learning to program, say, or learning to think like a computer scientist. So I call that computational lens, is sort of computational thinking. It's thinking like a computer scientist or thinking like a computer. The material, the skills, that's learning to program. And the discourse is really, if anything, the core, which is, it's about communication, right? All this stuff is about expressing and communicating and working together. And it's about creating the tools, the structures, the pedagogy, the situations to enable every kid to succeed. And fundamentally, it's a question of equity. And we see this all over the place, right? Because a lot of our students can't connect, say, computational content to their, can't connect computational content to their experience, interests, and needs. And moreover, even when they can, the social structures rarely exist for them to support them when they try to do that. And then in addition, even if we get there, the tools that we use in the curricula are structured with naive conceptions of how we learn. But we're not coming in this alone. You've seen lots of stuff. I build a lot on Yasmin Kafai's work and Michelle's and Paolo's, and we all, or at least I build on their work. I don't know if they build on mine. But there's a lot of different ways to go about it, and we're not really going in blind, thankfully. And so in my own work, I use that basis to try and understand the mechanisms of what happens when people work together. I try and develop tools. I try and structure and support spaces in which people learn, because these things don't happen out of context. And I try and find ways to communicate not only to teachers, but also to students and to researchers what people are learning. Because if you don't see how you're learning, if you can't see that connection, if you can't see what's being expressed and how it's being expressed, then it's a lot less meaningful. So I do that across a bunch of different projects in my own work, and I'm not going to talk about all the different projects, but I'm going to say I wanted to focus on one just as a quick note, which is this is one that's currently active for the degree that museums are active. This one is at two big science museums in the United States, one in New York and one in Berkeley, California. It actually connected to Michelle's university, Professor Wilkinson's university, but it's called Rainbow Agents. And in this, kids work together to learn computer science through communication. So it's not just about one kid coding, it's about two kids side by side in the museum, or multiple kids near each other in the museum. Again, during COVID, not so great necessarily, but who may not speak the same language, who may not have any background in computer science, who may not know what they're doing at all vis-a-vis computer science, but we frame it in terms of building a garden. And so these kids communicate and they know what it means to plant plants and to do these things. And there are all these sorts of triggers and various ways that the game itself is both A, very fun, B, about aspects of computer science they may not be seeing in their, even if they do have Scratch in school. It's about concurrency and parallelism and these kinds of things, which I think can be very expressive and meaningful for kids, but maybe they feel very far away, they feel very complicated, but they don't need to be, because a lot of this stuff is, how can I use this to make something? And so that's part of what this exhibit focuses on, is how you can use these really powerful tools, these really powerful ideas in computer science to build something. And so they build together. And so again, it's about building these computational literacies, building this communication between people around the table, what's going on. People walk up and walk away in the museum through this sort of creative play, building creative agency to learn and communicate and build, because they get tools and words and systems to communicate with other people in the museum, and then also take it back to their class. Really powerful ideas like agent-based modeling, concurrency, state diagrams, these kinds of things. But there are any number of questions we can ask about this. I'm not going to go too deep on all of our research questions, but the short answer is, who walks up to a game like this? So as you could maybe guess, we wanted to design it so it wasn't just the kids who already knew computer science, and it wasn't just sort of demographics that may already feel comfortable in computer science, or even just kids who already feel comfortable in computer science, but that it connected with different people, variety of people. Everyone can find a space to sort of connect around this this thing and feel that their experience is valued, feel like they have something to add, that they don't already need to be an expert. We found a bunch of things out of this, and I'm not going to go into the specific research findings too deep, but a lot of it is about how you can motivate people to actually communicate deeply about what they're doing, about what they're creating, and what are the tools and ways that you can motivate really meaningful discussion by people who may not know each other, and might not even speak the same language, might not even speak the same, or might not know anything about computer science. How can you enable them? How can you design environments where they can really deeply communicate and work together and create something together? And so again, the big question: how can we create these social spaces to build this creative agency through computational literacy? There's sort of three takeaways I'm going to leave you with before I let Michelle go, is that it's not about being the best coder. It's not about the most complex tools. It's not about the most complex code necessarily. It's about creating those conversations where people actually have to work through this stuff together, where they actually are invested in the problem, they're building through the problem, and connecting to their lived experience, the context, and thinking a lot about the space that it's in and how to use that space and how to use that context and use the kids' prior experiences, and leveraging their delight in creating stuff with other kids. It's almost cheating how much fun it is to watch kids learn computer science around a game like this. So thanks, everybody. I'm going to let Michelle take it away.
Obrigada, Matthew.
Okay.
Michelle, pode começar.
So I'm gonna, while I share my screen, when I came in, it looked like you were watching presentations. So I want to invite everyone to take a stretch break or something. I know that these can go for a long time, and I will set my screen up while that's happening. Okay. Is that visible to everyone? Great. All right. So thank you so much for inviting me and for being here today to listen to a little bit about some of the work that I've been doing. My name is Michelle Huda-Wilkerson. I'm an associate professor at the University of California at Berkeley. And I want to talk about specifically expressive scientific computing. And I use all three of those words very deliberately. A lot of these ideas build, as Matthew said, on some of the ideas that you likely heard from Dr. Yasmin Kafai, from Matthew, and from other people in the winter school. So my research lies at the intersection of computing tools and cultures. As educators, we've come to a place where computing is generally understood as something with the potential for expressive practice. And I'm sure that you've seen lots of really great examples of that so far as part of this series. Whether or not it lives up to these claims for everybody, computing is often described in our field as something that can be creative and artistic and expressive It's a way for students to engage socially with one another and civically with the world around them. And Yasmin Kafai has really started moving us all in the direction of thinking of it as participatory. But then often when we think about how we see scientific computing specifically in schools, it doesn't really meet the same standard as expressive computing in this more broad way. So when we talk about thinking or talk about using simulations or data visualizations in school, they're often treated as just information sources, or maybe environments, virtual environments where students can do experiments. But rarely do we treat scientific computing in schools as the kind of interpretive, representational, expressive practice that other forms of computing and digital media have become for children. So rarely do we treat these things that are like simulations, visualizations, and data sets as texts that are created by humans and can be modified by humans and contested. It's as if our thinking about our relationships to the world around us, even though that's very personal, right? When we think about what makes us wonder, what makes us feel things from day to day, what's impacting our lives and the lives of our children, for some reason that doesn't translate into the science world when we think about how computers sort of play a role in science. So since graduate school, I've been in pursuit of these personal and interpretive and collective ways of understanding the world through computing. At its best, I think of scientific computing as a way of enabling collective and expressive imaginations of ourselves and interaction with the world. So my colleague Brian Gravel calls these experiences of science experiential unseens. So we feel hot on a given day, or we feel sort of a breeze. We don't see what's happening, but we really wonder about it. And that's sort of the basis of a lot of scientific reasoning. And I'm interested in taking these experiential unseens, these things that we care about and feel, and making them visible through computing. So I would argue that scientific computing tools specifically, not just media, not just expressive tools, but scientific computing tools can offer some new ways for us to think about and engage with the world. And my goal in my research is really to at once produce tools that allow students to be expressive and scientific at the same time. So here are some examples of those tools, and I'll give a few more examples sort of as I go. My work assumes that scientific computing can be that expressive social and civic practice by positioning students as authors of computational artifacts, and specifically scientific computational artifacts. So instead of just readers that extract information and patterns from a simulation or from a data visualization, they're creating those things themselves. In my design of tools, I try to create experiences that link expressive practices that children already enjoy. So things like telling stories or sketching or building crafts to enter and introduce computational constructions. So craft and drawing become the building blocks of computing and programming. This focus on student authorship is always going to lie at the heart of my work. So I want to give a couple of examples and videos of what these tools look like and the kinds of work that students do with these expressive scientific computing tools. And the first example is from the SimSam project. This was a collaboration with my colleague Brian Gravel back when I was an assistant professor at Tufts University, and he's still there. This project sought to support students in creating their own simulations of molecular phenomena. So anything that involves particles that move around and hit each other, or that kind of thing. This work builds on my former advisor's work, Ray Walensky. And really what I wanted to do was take some of his work and make it more accessible and expressive, again, sort of centered on how students are thinking of ideas at a younger age. So Brian and I created a platform where students start by modeling phenomena like evaporation and condensation using drawing, craft, and eventually stop motion animation. And we hoped that, again, by building on things that students already enjoy and know are expressive, like drawing, that they would start to focus on particles, motion, and interactions, these scientific aspects of what happens in the world before they got to computational coding. In doing so, they would isolate and highlight the benefits of computing for understanding these systems a little more specifically. So I'm going to show a quick video here. Let's see if we can, of how this tool works. So here you see, it's a little hard, but you can, this is stop motion animation. So the student is taking pictures as they move craft materials on a flat surface. And then they actually can create little objects from their craft materials, and those become programmable objects. And the students can then double click and show the objects how they're supposed to behave. So they're programming the objects through demonstration. And while this is still quite simple, it very quickly allows students to see the ways in which computational simulations might be limited or might help them learn to generalize and sort of describe phenomena scientifically. So in the first model here, the smell was not moving from the orange to everyone you would expect, but with a few more changes to your theory of how smell spreads, we should get a much more accurate scientific model of smell spread over time. And so students can iterate, change their ideas, test their ideas through this primarily visual means, and they're always looking at their own work, their own productions. Here's another example of work students did with this, where we explored condensation and evaporation. So here you see a simulation students created with rain coming down, creating a puddle, and the puddle also evaporates, creating water vapor that goes up into the sky. So again, thinking about those, what's unseen and how can we think about making that visible and theorizing about how some scientific phenomena happen. The second example I want to talk a little bit about is data sketch. So in this project, we're interested in how young people think about, use, and create data visualizations. And here we're especially interested in highly interactive and contextual visualizations. So sometimes when we think about visualizations, we might think about a bar chart or a line graph. But when we go to the New York Times or a lot of more sort of information-rich sources these days, visualizations can be any kind of thing. And so we're interested in how students develop literacy around these much more visual, contextual, grounded representations. So one piece of this project involves allowing students to create their own data visualizations, again, from digital ink sketches. So students sort of draw objects, and then they can link attributes of those objects, properties like whether the object is visible or not, how big it is, where it's positioned on the screen, to data sets, so that a change in the data set is reflected by a change in the actual visual object. So I'm going to show another video here, what that looks like. So here's a data set of weather, and it's daily weather for a month. So it includes things like the temperature, rain, cloud cover. And a user can sketch whatever objects they would like to represent those things. So this sketch is quite literal. So they're creating a cloud. The cloud is visible when there's a lot of cloud cover, and it's not visible when there's not a lot of cloud cover. They also drew some raindrops. The raindrops get bigger as precipitation increases in this data set. And there's an arrow that will both change color to indicate temperature and change direction to indicate wind speed and direction. And so then when they play their visualization, they can see how these different variables in their data set may or may not be correlated with one another. So we were hoping to leverage the flexibility of this tool to explore the impact of narrative and iconography on how students think about and use visualization tools. And there are a number of different ways that they actually ended up using these tools to explore data sets. And what's interesting about this is that they were thinking about the role of data visualizations in a variety of ways. So some students wanted to create very, very precise and accurate visualizations so that they could sort of reproduce the patterns in the data that they observed. And that's sort of what we are that's what we emphasize when we teach data visualization in schools, and what's emphasized by things like line graphs and bar charts. But other students were more interested in holistic relationships between variables. So they didn't really care about if the numbers were exactly represented, but does wind tend to be higher or lower when it's hot outside? So looking for these more general relationships. And there you saw much more interesting uses of icons. So visibility here is a big eye. You see wind as sort of this wavy object. And what the student did is made these all fade in and out so that you could just see what faded in and out together versus what did not. A third way that students used this tool was to actually create prediction and recommendation systems. So what we see on the bottom was a child who wanted to use weather data to tell drivers what driving conditions and driving safety would be like over the bridge. Here in San Francisco, we have many bridges, so it's very important to know what the weather will be. And so it's a little hard to see, but you can see a cloud covering this car up on the top, and that cloud would indicate whether the fog would impact visibility for driving. And then on the bottom, there's a number of these little squiggles behind the car, and that was actually meant to represent wind, just to tell drivers, hey, it's going to be windy today, it might be more dangerous. And so it's interesting because we very rarely think about in classrooms data visualization as a prediction or a recommendation system, but this happened all the time when students were able to actually create their own visualization. Sort of the role of data visualization and its purpose shifted for them because they had this flexibility. So the last project I want to talk about very briefly is called Writing Data Stories. This is a collaboration with my colleague Chris Gutierrez, Holly Lynn Lee at North Carolina State University, Bill Finzer at the Concord Consortium, Tim Erickson at EAPS Media, and a number of other people. Here we're trying to kind of consolidate working with data and storytelling into one environment. And so the idea behind writing data stories is that students can weave together their personal and social histories with scientific data sets and really explore any tensions or differences between personal experience and bigger data sets, or sort of where they see themselves in those data sets. And so for this project, we're developing a data storytelling tool, which includes a number of what we call moments. So students create moments that can include a visualization. So here we see a map with particular proportions of racial categories that are used here in the US. We see a data set over here. There's a news article about tracking the coronavirus in California. There's some text interpreting. So the idea is that students can bring together a number of resources, not just a data set, but also personal stories, photographs, images, videos, whatever they would like, to sort of weave together and integrate these different pieces of understanding data. And in working with students, we see them do some interesting stuff. So these are just snapshots from one student who started to explore environmental racism and became really interested in how much people feel like they have a voice in fighting environmental racism. And so she looked at a data set of surveys with community members and realized she was sort of expecting that fewer women would feel comfortable sort of advocating for environmental racists or for, fighting environmental racism versus men, because women, here we have it highlighted here, there are more women put down by men every time they're talking. There's a lot of politics in every conversation and women get put down. And yet she found in her analysis that more women felt like they could make a change by talking about politics than men. And so her sort of intuitions were violated, but she was able to weave together all of her reasoning, sort of moving back and forth between text and data. So I'm going to stop there. and make sure we have time for Gracias. But thank you for listening, and I'm happy to answer any questions later.
Muito obrigada, Michelle. A gente vai passar para Gracias e depois a gente faz as perguntas, tá bom?
Can you see the presentation? Yeah. Okay. So thank you everyone. I feel really honored to be here. It's always a pleasure when I have the opportunity to speak with audiences from Latin America. I'm really passionate about it, and thank you. So today I'm going to talk about the role of language and cognition, particularly for designing spaces for engineering and science learning. And I will be talking kind of like a 10,000 feet overview of the work that I have been doing in this space. As you heard, my name is Grace Perez, and I'm the McDonald Family Assistant Professor in Civil and Environmental Engineering at Tufts University, and the School of Education there as well. And a little bit about me is that, just like Paulo mentioned at the beginning, I'm a learning scientist, I'm an engineer and a science educator, and I'm an Afro-Latina, a Spanish speaker, a scholar. And very often I am the only one. And my passion for all of this research actually started with my name, when my mom decided to name me after Grace Kelly. And a misspelling in my birth certificate that I realized when I was 10 years old made me realize that I needed to behave like this Grace Perez, whoever she was, and that I was not actually Grace. And then it started my quest to understand issues of language and identity. And as an engineer in studying at the University of Puerto Rico in Mayagüez, I often took the courses in civil engineering in Spanglish. And I know some of you may be familiar. I know, like in the border between Uruguay and Brazil and other countries near Brazil, people speak Portuñol and other varieties of language. So there I was in an environment that was completely hybrid, and where those language practices were actually welcome and invited for us to make sense of the things that we were learning. So that takes me back to this idea of what is the role of language. From my own personal experiences, I started thinking and questioning, what is the role of language and experiences, what a lot of people call culture, in science and engineering learning environments. And I will give you 3 examples coming from the research that I have been working on in the last couple of years. One, on how can we think about language and experiences when we are designing virtual learning environments? How can we think about these factors when we are designing audiences? And how can we think about language and experiences when we are reimagining learning opportunities for students? And the first one, the virtual environments, I want to talk to you about a project that started at the Stanford Science and the City Research Lab that is led by Brian Brown, who was my advisor. And we decided to challenge or expand this idea that is very often sold by a lot of technology companies, to defy reality through virtual environments. And instead of defying reality through virtual environments, we decided that we should incorporate the language, the images, and the sounds of the communities. So we embarked in a multi-year project of, it was 3 years in total, working with students and schools in the Bay Area, where we identify features of what matters to the communities where we were working on. And we incorporated people who look like the students who were in the classroom, and the science and engineering in their local context. And instead of jumping in the idea of defining reality, we decided to be inspired by the reality of the neighborhoods where those schools were placed, and show the students the science and engineering in their day-to-day. So we incorporated, as I mentioned, images and sounds that were appealing to the students, images of the local barber shop and the local convenience store with people who look like them. The lesson was about food chain, and we also incorporate a scavenger hunt of places where the students could find sources of food and the quality and nature of those sources of food. And the places where the amount, the quantity of dialysis centers in the neighborhood. And now we'll show you a very brief clip of one of the VR360 videos that we incorporate in the lesson around food chain.
Have you ever been in a barbershop or hair salon waiting for your turn?
Okay. And what we found from this research, from incorporating language, images, and sounds from the community into the lesson and showing students not only the science out of a space or in the classroom, but the science that they experience in engineering day to day, we found that students describe and talked about engineering and science as something normal. As an example, I have brought up an excerpt from one of the students who mentioned it seemed real, and I didn't even know that we were learning science because it helped you understand what the main content was. You don't know that you are learning science, it's just normal. Students also talk about a holistic view of science, and they changed their attitudes towards science in a way that they started to see science as a tool for problem solving, not only at school, but also in their communities. Another aspect that I have been thinking about when it comes to language and experiences and how we can incorporate them to improve the teaching and learning of engineering and science is this idea of audience. So for this project, I pondered two different issues. So issues of representation and issues of language use. So what I did here is with a sample of undergraduate students, all of which were pursuing degrees in STEM in the United States and grew up in Spanish-speaking households, I asked them, how would they speak? What language will they use in the different contexts? The contexts were either academic or at home. And they were either talking at the university or at home with their parents or professors. And they were either talking about academic topics or personal topics. And what I found from this work is that we need to move beyond this idea that availability, the mere availability of opportunities will ensure that students will take those opportunities. And we need to move beyond this idea of simply having a seat at the table because that is not enough. What I found is that actually audience drives the language practices of speakers, meaning the way the students talk about science and engineering depends on who they are talking with. So meaning whoever is in front of the classroom play a key role in what language practices are legitimized in the field. We also found a less strong effect of topic and also of place, which can be shown as in the new framework that I'm putting forward, where I explain that language has a strong influence on the language practices of the speaker when it comes to science and engineering. And as an example, I want to show you what Leila, one of the students participating in this survey, shared with me. She spoke about her experience at NASA and how she worked with people who come from Mexico. I don't think one of her mentors is of Mexican descent. And she said, I don't think I've ever even told him that I'm Mexican. I don't think we've ever spoken Spanish. And I just feel like weird about it because it's like, we are all here to do is research. I think the engineering students feel less comfortable saying, okay, I'm going to speak in Spanish because it's seen as less professional and because we are in the United States and everyone speaks English. And that was a common pattern across all of the students where they mentioned speaking, bringing the language practices of their communities and their families into the classroom as a no-no, because it was seen as less professional and it was seen out of the norm, but particularly because they didn't have role models. So they describe Latinx professors as mythical entities because they do not exist. In the third aspect of the work that I have been working on recently is around learning experiences and how we can reimagine learning experiences to incorporate the language resources of communities, particularly for the purpose of engineering design. So in this work, I draw on justice-centered science perspectives that basically see learning, cognition, and knowledge as distributed between the physical space where we are, also humans, and then the social arrangements where we exist, meaning all the things around us contribute to our learning, and learning is not something that only happens inside our brains. I also draw on the frameworks of design justice that basically challenge these ideas of exceptionalism, of single people creating companies in a garage. And also a long tradition of situated cognition that focuses on learning taking place, that learning being contextual in a specific place. But I expand this idea to think about the near context, meaning the classroom, and the distal context, the communities that we claim membership in. And I will go really quickly. What happened basically in these experiments is that students were engaged in different design experiences, where some of the students were placed in experiences where they only engaged in engineering design in English only, and others did so in both languages. And what I found is that those students who were in the both languages condition and in the English only condition, at the end, they both produced the same number of ideas. But in the different iterations, those who were in the both languages condition brainstorm a greater number of ideas earlier in the design stage. And not only those ideas were of greater quantity at the beginning for those students who were in the bilingual condition, but their details were more, they created more specific details. For example, let's look at Tico, a software engineering sophomore, who talk about the details in the toaster oven that he designed as minimalistic, like Apple. On the other side, Mark, a mechanical engineering senior, gave us a very detailed description of the aesthetics of the toaster, and he compared it with other people with cultures, other cultures like the Mayans and the wavy mosaic patterns with different colors. But not everything is lost. When the students were in the English only condition, we were able to activate the diversity of their perspective by explicitly asking them to incorporate culture and language features into their design. So this work has implications for research, both for research in applied linguistics and thinking about who professors are and the kinds of messaging professors are sending to students. Who is creating designs? Who are the people who create designs and solutions for all? And who are they creating those designs and solutions for? It also have implications about the ways that we imagine language in the classroom and expanding these ideas that challenges the stances of language and consider language boundaries as an important factor for students to deploy their language. This work actually shows that audience, topic, and many other factors may be contributing to what kinds of language practices students deploy in the classrooms. To summarize, what the heart of this work is who students are what they know to be true in their community and needs to be central to the teaching and learning of science and engineering. I am not arguing here with my work that we shouldn't teach the nomenclature of science and engineering, but I am joining a growing number of equity-oriented scholars that are asking for us to center the voices of communities that have been traditionally marginalized in the field. So I want to invite all of us to imagine the kinds of world that we will hope to create and to include the voices that those worlds will make, the voices that will make those worlds possible for us. So thank you so much. And I want to thank the funding, the funding sources for this work. And if you need anything, feel free to drop me a line. And thank you so much.
Muito obrigada, Grace. Paulo, você quer falar algo?
Deixa eu só desligar a tradução. Thank you so much, Matthew, Michelle, and now we'll do questions.
Teve algumas perguntas. Desculpa, Paulo, está cortando um pouquinho, não sei se eu estou te interrompendo. Vocês me ouvem?
Sim, dá para te ouvir, Cássio.
Paulo, tá cortando um pouquinho? Eu vou começar a fazer...
Não, eu só falei que a gente vai para as perguntas.
Tá bom, obrigada. O pessoal colocou bastante pergunta no chat para a Michelle. Todo mundo achou que ela falava português, mas ela está usando o tradutor. Muito bem usado. Então, obrigada por ter respondido já várias dessas questões, Michelle. Surgiu uma questão que me remete a uma outra também, então vou fazer essa pergunta, depois a gente pode passar para as outras se der tempo, que eu acho que vale para os 3 panelistas. Então, perguntaram, né, sobre se esse tipo de ferramenta, né, já faz parte de alguma disciplina, né, ou do currículo, ou se eles são geralmente em atividades extras, né? Acho que cada um de vocês tem um diferente setting, assim, né, um lugar diferente de foco, mas todos talvez transitem por diferentes contextos de ensino. E quando a gente pensa nas abordagens e nas ferramentas que vocês estão trazendo para a gente vê que elas são muito poderosas, né, para a criação de projetos mais abertos, mais expressivos, mais autênticos para os alunos. Por outro lado, elas têm um potencial grande, né, de integração com o currículo, de serem acessíveis, né, para todos os alunos, até com uma questão de equidade, né, de ser para todos, uma vez que a gente inclui isso no currículo formal. Mas quando isso acaba, às vezes, entrando dentro do currículo, esse potencial construcionista das ferramentas, às vezes acaba sendo um pouco limitado, né, pelo contexto da sala de aula, né, por ter que cobrir o currículo. Então, eu queria saber a visão de vocês sobre, talvez, os potenciais e os desafios da integração dessas ferramentas e dessas abordagens no currículo formal das escolas. E daí vale para os 3, se alguém quiser responder. Se a pergunta não estiver clara, eu posso refazer, falei demais.
I would love to hear what Chris and Michelle have to say, but I definitely have thoughts about the challenges of integrating, but I would love to hear them first. I know Michelle has thoughts. There's 0% chance that Michelle doesn't have lots of thoughts about this subject.
I might need to hear the question again because I was still translating and answering questions in chat. I'm sorry. So.
Obrigada por comentar, Michelle. Assim a gente faz de novo. Eu falei muito, mas eu acho que a minha pergunta é principalmente sobre os potenciais e os desafios da integração desse tipo de ferramenta no currículo, uma vez que elas são desenhadas para serem abertas, construcionistas, mas a gente sabe que dentro do currículo formal, às vezes as coisas acabam saindo um pouco diferentes.
Yeah, I can say something very briefly, which is that it is a challenge, and I don't think we've figured it out, but the way that we've been able to, most of our research happens in typical schools during the school day, and the way that we do that is by partnering with teachers very early on, so that we integrate with their existing curriculum. So we ask them, what topics are you going to be teaching? You know, what do you hope your students learn from this exercise? And then co-develop curriculum so that it feels like it's more of a fit and not just an extra, 3 or 4 weeks that they have to do on top of what they're already teaching, but instead it's a supplement.
Muito obrigada, Michelle. Matthew, você quer continuar?
Okay, I'll say a couple things. I mean, so my work is maybe it's less interesting question for my work. Not that the question is bad, but that I work primarily with computer science, which is a new subject, and that it's in lots and lots and lots of schools in the United States now. Many states require it at many levels, but honestly, the curricula are all brand new. They're often quite bad, and so when you integrate, they can see the value pretty quickly in learning to program in a more creative way. Because honestly, when you're trying to learn to program, if you're following a very strict curriculum that doesn't allow for creativity, honestly, the learning to program will go more slowly. And people can see that, and that's not something anyone wants. So in effect, I'm just cheating. Yeah.
I will add to what Matthew and Michelle share. So one thing is to actually have the buy-in of the teachers and start, like Michelle mentioned very early on. A lot of the projects that we have been working on are multi-year projects that start with the teacher in mind and with the communities as well, and the students. And in addition to that, this idea of integration, and we don't have to only teach computer science. And in my own experience as an educator, I brought the parents as experts in many areas. And I tried to mingle that with the CS week, with the engineering design challenges, in a way that the students saw the purpose and value of what they were doing beyond the classroom walls. And that it was not only let's go and do CS, but let's go and do CS. And we on the side are also going to learn about angles and all of these other things. Of course, this requires a lot of preparation and a lot of work. So I'm not diminishing the amount of work and energy that this requires, but it's not impossible.
I'm going to say one of my other projects that I didn't mention is thinking about ways that you can have justice and equity oriented assessments for computer science in classrooms. And the original design was that it was going to be deployed in every middle school classroom in New York City, but COVID kind of interrupted that. But one of the things about how we integrated was we did co-design with teachers and co-design with students and try to figure out what people wanted. And a lot of what was meaningful was finding ways that were thoughtful and based on kids' experiences, that also gave information back to the teachers and back to the students about, to some extent, not only what they knew in content, but also what computer science is and what it's useful for and how it connects to their lives. And that's just information that the students often don't have, but it's also information that the teachers might not be trained in, because very few of the teachers have a background in being trained as computer science teachers, or even teachers who have already been trained to use computer science. So that was one sort of way that we connected with lots of teachers and classrooms.
Muito obrigada pelas respostas. Eu acho que o Paulo tem uma pergunta para fazer, conectando também com a pergunta da Inara, que ela fez aqui no chat. Paulo, você quer falar?
Eu só parei o vídeo porque a conexão estava meio ruim. So, just wanted to ask, because this is the first winter school in learning sciences in Brazil. A lot of people have never been at the conference, or they don't know the community very much, and they're trying to get started. So, how does it feel to work in this community in the learning sciences, and how has the type of work that you do, how has it benefited in being in this kind of interdisciplinary community? And if you have any advice for newcomers.
I'm going to start. I talk a lot. As a newcomer, a rookie myself in the community, I have found that the interdisciplinary nature of my own journey has been not only welcome, it has been nurtured in the community like the learning sciences, with a strong emphasis on issues of equity and racial justice. And so you can bring ideas around science and engineering together with all of these ideas of equity and social justice and racial justice, et cetera, et cetera. Yeah, I will say that there are different, there's a different perspective of what learning means and where one can find learning, not only in someone's head, but beyond that. And I have really enjoyed to intellectually play with those ideas with people in the community. Yeah, so I feel the possibilities are endless, and people tend to be really welcoming to each other's ideas, which I really appreciate.
Yeah, I would agree with all of that. I feel like because my work, there's some science components and some math and statistics and computer science, I try to publish in those fields, and I also publish in the learning sciences. And very often when you try to publish in math education, I will get, questions of like, well, is this really math or is it math enough? That does not happen in the learning sciences. They're really interested in the phenomena and how they intersect and how learning in one field impacts learning in another field and how fields are changing right now. So I 100% agree with you can come in with all kinds of ideas, and the learning sciences really embraces that. Sometimes that can make it feel very large and kind of like it doesn't really have a shape or an identity, but I think as long as you just embrace that and you go in and you say we're a flexible field that's open to new ideas, then it feels good.
Matthew, gostaria de falar?
I'm happy to add up, but my yes is my feeling. I mean, one thing that's really nice about the field is, and I think this is true for a lot of educational research fields, is that people try to help you. And this is, fundamentally what education comes down to is connecting with other people and helping people grow and supporting people in their growth. And that's why why education and learning are just really welcoming places to be across the whole field. And especially I think in the learning sciences, where the interdisciplinarity means that there's fewer bounds to that space. I think that I hope that we can make it very welcoming to all of you.
Muito obrigado pelas contribuições de vocês. Foi excelente esse painel, acho que todo mundo aprendeu muito, a gente sai com muitas coisas para pensar. Paulo, você quer falar alguma coisa antes da gente ir para o intervalo?
Não, só o Marcelo levantou a mão, então, mas a gente tem literalmente 30 segundos para encerrar, então só queria agradecer aos panelistas, e daí a gente vai, acho que sem intervalo do Learning Sciences Japão, não é?
Acho que é depois do intervalo.
Tá.
Depois.
So, thank you, Matthew and Graces. It was really an honor and a pleasure to have you here, and we'll keep you posted with all the questions. And, many people are asking about collaborations, how they can use the tools, how can they can like learn more. So we'll send people all the information and keep you posted about how this wonderful initiative develops. So thank you so much. and see you around.
Thank you.
Bye, thank you.
Thanks. Ok. Então agora tem um intervalo, é esse?
A gente volta às 3h.
Vamos só, desculpa, Cássia e Paulo, só antes do intervalo, lembrar para quem ainda não respondeu aquela enquetezinha que a gente fez, que a gente mandou aqui no chat, dá uma passadinha rapidinho lá, só para ver, só para ajudar a gente a montar salas de bate-papo, um tema um pouco nostálgico, né? Mas para a gente montar essas salas para a nossa sessão às 5.
Vai ser no UOL?
Vai ser no UOL, Fala o UOL.
Fernando, tem como mandar o link aqui de novo, só?
Claro, eu mando aqui no chat de novo.